So last week I make a mistake. And I think I posted the correction on Avenue to learn, but I want to show. So I make a mistake over here. Okay, I make a mistake over here because stress critical is equal to pi squared EI over L squared A. Okay, I did not divide by A, so we're going to do that again. So this is wrong. Okay, this is wrong. This is wrong. So therefore, stress critical. So I'm going to say this is the correct one. So it's equal to stress critical is equal to pi squared EI over L squared divided by A. So this is our pi squared, and our Young's modulus is 10.1 times 10 to the power 6. And our length with the equivalent extended Eulers is 0.7 times 20 squared. And then this is our I, which is 2.857 A4 divided by 12. And then the area, which is equal to 2.857 okay, squared. Okay, there's a square down here. So this symbolizes the I over here. This is our A. And then the whole thing will be equal to 4. The whole thing will be equal to 4.375 times 10 to the power 3 over A squared. Okay. So if you press the calculator, what you will get is 42.382 times 10 to the power 3 A squared. And then this will be equal to 4.375 times 10 to the power 3 over A squared. So we have A to the power 4, which will be equal to, so 4.375 power 3 divided by 2.38 to the power 3. You get 103.22 times 10 to the power 3. Therefore, A will be equal to 0.567 inches. And B will be equal to 2.857 multiplied by 0.567. Okay. So 2.857 times 0.567 is equal to 1.62 inches. Okay. So this is the optimum geometry where fracture -3, right? Is it? Yeah. Okay. So what you see is the optimum geometry where buckling will occur at this, or both planes will have the same resistance to buckling. Not one is stronger than the other plane, or the other plane is stronger than either plane. Okay. Right. So the next thing that we're going to do is eccentric. And everyone okay? Yes. This term, this is when you press in the calculator all these numbers. Okay, then you get 42.382 times 10 to the power 3. You get what I mean? Okay, yeah, I know you. I did it like a cooking show, right? I did not press my calculator. You did not realize that, right? Some of you say I'm pressing calculator, wasting your time, so I write it out like that. So the next one we're going to look at is eccentric buckling. Now, before we go into eccentric buckling, I like to quickly recall eccentric bending. Okay, so let's recall eccentric bending. So you all did this in 2P, right? So in 2P, what do you do? Okay. So we are going to analyze a non-buckling structure now. Just to quickly recall, okay, eccentric bending. So if we have a structure looking like this, I think if I draw this, you guys will be very familiar. And over here, we have two lines. And I'm going to label point A and at point C. Okay. So point A, we have a loading down here. This is P. And P is offset from the centroid at point C at a distance E. Okay. So does this look familiar to all of you? We've seen this before, right? Okay. So let's focus on point C. Okay. We're going to focus on point C. So over here, we have from point C, P is going to generate a moment at point A, and this will be equal to P multiplied by E, right? At point C, so let's focus at point C now. We have to have a reaction P, okay, because of Newton's third law. And we have to have a counter moment over here, okay, moment at point C. So when we write, so I will again have over here, I'm going to put a down here. A corresponds to the cross sectional area. So what we see over here is we have a normal stress is equal to P over A plus or minus MEY over I. Does this look familiar to you guys now? Yes? Okay. You learn this in 2P. Okay. Over here, this is due to the what? And over here, this is due to the now question for you, which one will fracture the load or which one will fracture the structure? Anyone? Is it P over A that going to induce the fracture, or is it MY over I? Anyone can tell me why? Which one? They are gas. You are here today. And you will find for you. So which one? Yes.
Would it be the bending of the structure?
Yeah. Why?
Because
It's all to do with angle management.
Yeah, it's gonna be
No, 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 no. Don't think about the equation. Think about what I say. It's all to do with what? Anger what? Management. What do I say by that? How many of you have anger issue? I do. Okay? Why do I say that? If we're going to break the ruler, we're just going to rely on pure tension weight break. Yes or no? So when it doesn't break, well, pulling, what will you do? You want to what? There you go. Hey, don't memorize any of this. Are you clear? Just remember about what? Anger what? Management. So it can't break what do we tend to do? We tend to do what? Flex, yes or no? When we flex, you will what? It will break. Okay, don't memorize these other things, okay? That's why I'm not teaching anything from the textbook. Okay? Right. I mean, the theory is from the textbook, but whatever, man, you can't remember the theory. Right. So this is eccentric buckling. Sorry, bending. Now I'm gonna, you're going to call, okay, yes or no? Right? Now I'm going to do eccentric buckling using what? Bending moment theories. Repeat again. We're going to use analyze buckling now, okay? So the next thing that we're going to do, now, it is different. Okay, it is different. What is the different? So I'm going to okay. So we are now going to go for eccentric buckling. Okay. So what will happen now is we have a structure and then we have this is our centroid. And the centroid not very straight. Come on, Eugene, seriously. Hey, what did I do? Pardon me. So this is our centroid. And then now we have a load P not acting on the centroid. Can you all see the difference now with centric and eccentric? So now we have a distance over here. This distance is our E. Okay. So the E over here, I hope you all will remember this. This is known as our offset distance. Okay. Now, what I'm trying to do is I'm going to prove to you, okay, in eccentric buckling, the formula is very different. Okay. It's not as straightforward as what we have before in bending. But what we have is chaos. You have P over A, and then you have 1 plus by EC over R squared, secant. And then you have 1 over 2 L over R square root P over AE. Okay. Yeah, some of you like, really? Right? I know how you feel. I felt the same when I saw this equation. So what we see over here, right? Why